What's up, everyone? This is LeetCode 5, longest palindromic substring, right? So, given a string S, return the longest palindromic substring, right? What is a palindromic substring? Well, a substring is a contiguous, non-empty sequence of characters within a string, right? So, we have to find a substring with this given string that is palindromic, and a palindrome reads the same forward and backwards. That's what a palindrome is, right? We've done a problem already in Lagrange 75 where I think we have to return true or false if a string is a palindrome. Basically, it's that problem combined into the fact that now we're actually checking substrings. So it's a little bit more complicated, but so those two things, right? We're combining substrings and palindromes, okay? We have to find the longest palindromic substring because the given string that we're given isn't always necessarily a palindrome, right? Like BABAD, that's not a palindrome, but there is a palindrome within it, right? And um so BAB, for example, would be a palindrome. The longest substring, that's a palindrome. ABA is also the longest substring that's a palindrome, right? Because they're both length 3. Example 2, right? BB for this would be the longest palindromic substring. Okay, so we're going to basically talk now about the approaches, because this problem has quite a few approaches, some more efficient than others. Let's talk about the brute force approach, right? So if you have something like A, B, C, D, B, A, right, whatever, we'll just say something like this, whatever. Well, the brute force approach would be like take this substring, right? Then take this substring, then take this substring, then take this substring, then take this substring, right? So naturally to find the substrings, it would be n squared, right? But then you have to do checking if it's a palindrome for all of those substrings, right? Because that's the nature of the problem, longest palindromic substring. So we have a linear time complexity for checking if it's a palindrome. So in total, that would be an n cubed solution, which generally isn't that efficient, obviously, right? Unless you're doing some crazy hard problem, generally when you have an n cube solution, something's wrong in terms of your approach, right? And same with n squared, but there are some problems that we've done that n squared is the best solution. It's not that common, but it does happen. Now for this problem, I'm going to show you the n squared solution because I think it's easiest to understand. And you will naturally know how to solve this problem if you come across it in an interview, because that's the point of this channel. I don't really want to show obscure algorithms. I just don't think it's that good for interviews. Like you'll just forget it or mess it up. I don't think it has that much value, personally. But there is an O of n. There's like a linear time complexity algorithm called I think it's pronounced Manicher's algorithm to solve this problem. Like I said, it's kind of obscure. I just don't think it's really worth understanding. You can if you want. I don't know. I mean, what interview would expect this? I mean, they're just they'd have to be pretty mean, to be honest. I'm just going to show you the O of n squared solution instead of that obscure algorithm because I think it's easier to understand, and it just naturally makes more sense. There's also a DP solution. That's not what I'm going to show you, but there's a DP solution, but I'm not going to show that because the space complexity is not O of 1, but this approach that I'm going to show you now is O of 1 space complexity. So this is actually, I would say it's the quote-unquote most efficient, but technically that obscure algorithm is the most efficient, but I'm not going to show you that. But you can look up that algorithm if you want. I'm not going to show you that, though. Okay, so let's talk about this. So to check if a string is a palindrome, right, we have two options, right? We can basically expand from the outside towards the center, or we can expand from the center outwards, right? Meaning you can either put a left pointer here, put a right pointer here, right? Compare those characters, and if they're the same, okay, that's good. Let's keep checking, right? So move the left pointer here, the right pointer here, right? And keep moving towards the center to check if it's a palindrome. Or we could also approach checking if a string is a palindrome by basically setting the 2 pointers at the same spot and expanding outwards, right? The left pointer goes here, the right pointer goes here, right? Now there's also an edge case where we might have an even number of characters like this. Because where would we put the left and the right pointer in that case? Well, in that case, we would just put the left pointer here and the right pointer here, right? The right pointer here, and that's how we would do it, and we would expand outwards that way. So whether there's an even or odd number of characters, that's going to change where we set our pointers, but we can still do the checking from the center outwards, right? We just have to be a little bit careful with our pointers. And that approach is what we're going to use, right? Expanding from the center outwards. Okay. And the reason that's good for this problem is because we can basically have conditions to where we stop checking or we stop expanding outwards. Like if we're at this B, right, and we're expanding outwards, well, when we go out of bounds here, we don't want to keep expanding outwards, right? So we're not like, you know, doing some unnecessary checking with all substrings that we don't want, right? Like for example, you wouldn't have like any redundancy for checking because um well the issue here, the issue with the brute force approach is that you're finding all the substrings, right? But then you also have to do the checking of the palindrome. But with this like expansion from the center outwards, you can kind of check the palindrome if it's a palindrome as you expand outwards, right? And so that kind of helps because you don't have to do one you don't have to find all the substrings and then check if it's all a palindrome, right? There's a lot of I don't know if redundancy is what I want to say, but it just makes the problem more complex than it needs to be when there's more like a more clever, elegant solution to basically check if it's a palindrome as you do the expansion from a certain character, right? So the way we're going to do this, right, is first of all, we're gonna find the longest length palindrome, right? Initially it's gonna be 0, right? Okay. And we're basically, what we're going to do, like, let me just take this string here, right? This here. We're basically gonna go through this linearly, and as we go linearly, we're gonna do the expansion, and do it that way, okay? So we're gonna go through this string linearly, so we're gonna say for I in range, length of S, right? This is gonna be for the odd length palindromes, right? Because we will have two cases, right, depending on our input string, whether we have an even number of characters or odd number of characters, you know, where we would have to basically set our pointers. Okay. Right, because if we have something like ABBAD, right, if we expand outwards from here, we'll never hit these 4, right? If we start at this B and we expand outwards, we'll get this, but we'll never include this A. If we start here and we expand outwards, we'll get these, right? But see how we'll never hit these 4, right? That's why we need to basically cover even length palindromes, because there are cases where we could have an even length palindrome, but we won't hit it if we set the pointers at this. If we set the left and the right pointer at the same starting character and we expand outwards, we won't hit that. We won't hit, like, we will never hit this ABBA, right? So that's a case where we would have to shift the pointers a little and check if we can find a different palindrome, okay? So the way we're going to do this is the case where we're going to set the pointers at the same starting place, right? So we're going to do that, and we're going to say while we're in bounds, right? So while this is in bounds and the right is also bounds, and of course if these are matching, that's a good thing, right? We can keep expanding outwards as long as we're in bounds and the characters match. And of course they'll always match initially because again the left and the right pointer are at the same starting place. So from here we're gonna basically check the window size, right? And if that is greater than the longest length palindrome, then we're going to set the longest length palindrome to whatever this window size is. Okay. Now, I've seen some people store the longest length palindrome so far, like the actual palindrome in a string, by doing string splicing. Basically, let's say we're at this B, right, and we expand outwards. Or sorry, let's say this was like this. Okay. Let's say we're at this B and we expand outwards, we get ABA. I've seen people store ABA right here, right? And as we find longer and longer palindromes, we would store it here. Basically do a string splice and store it in a string. The problem with that is it makes your program more inefficient, right? Because string splicing is kind of an expensive operation. So you don't want to be doing that. Basically doing that string splicing continuously. especially for like huge strings. So what we can do is basically store where we're going to start, right? So we would start here and how long our window is. So we would basically go up to here, right? And that way we can basically just store it in variables rather than doing any string splicing. And down here is where we'll return that. I'll explain that more later, but basically we're just going to prevent string splicing. That's the gist of what you need to know so that we don't make our program more inefficient than it needs to be. And I think if you do that in an interview, it'd give you some cool points, right? And shows the interviewer you're thinking about this stuff, which is really good. Okay. And then down here, we're going to do the same thing, right? That's basically it. That's check expanding outwards and until one of these conditions is broken. Right? And we keep doing that for every point because we're in a for loop, right? At every point in our string as we're going through it linearly. But we also have another case where it's basically the same thing, except we have even length palindromes, right? Like remember what I showed you? We could have something like A, B, B, A, D, right? In order to hit these four, what we would need to do is we'd set the left pointer at I and the right pointer at I plus 1, right? So that way, let's say when we're here when we're in the for loop and we get to this B, set the I here, right? The left pointer at I, the right pointer at I plus 1. So now when we expand outwards, right, these B's match, okay? The left pointer will go here, the right pointer will go here, these match. So now that's our longest palindrome, right? And so this is what is different here, is basically just this, the right pointer, it's set to I plus 1 instead of I. But it's the exact same as up here. It's just where you set the pointers that's different, right? So yeah, and that's really all it is. And then down here is where we'll return, and we'll go from start to start, right? Plus longest length. Okay. Should be it, I believe, right? Because if we have something like this, right? If we have something like this, our start should be at 0. Which is where the left pointer is. And the longest length is going to be what? R minus L plus 1. So 0, 1, 2, 3. 3 minus 0 plus 1 is 4. So we would do plus 4. So our string splicing would be 0 plus 0 plus 4. And remember string slicing, right? The first thing is it's basically inclusive, exclusive. So our string splicing would go from index 0 to up to, but not including 4. So it would technically go from 0 to 3 inclusive. So we would do 0, 1, 2, 3, right? Right? Because this is what our string splicing looks like. But remember, this part here is is exclusive. So technically you go from index 0 to index 3. 0, 1, 2, 3. And what do you know? That's our longest palindrome, right? But the reason we do it like this, the reason I'm doing it like this, is because technically you could do something like palindrome and then right, something like, you know, basically do your string splicing in here, right? But the problem is that that's really inefficient if you're continually doing a bunch of string splices to update your palindrome and store that string. So in order to prevent doing that, we can just do it like this, by basically utilizing this here and this here. And whoops, I should, update this, and that'll make it more efficient. Okay, I know my code's a little weird, but again, I'm just doing some slight optimizations. Okay, let's see what we did wrong here. R minus L plus 1. Oh, this right here. Sorry, I don't know why I did this. I forgot to I accidentally copied it twice. I don't know what I was thinking. Whoops, slight error. Sorry if that was confusing you. I wasn't paying attention. Oh, I found my other error. Sorry. This returns is inside the for loop. Obviously, it shouldn't be. Little silly mistake. Okay. Now you'll notice something, which is that this is obviously, this here is the same as this. It's just the pointers that are shifting, right? So in an interview, you might want to just go ahead and put this in a function, in order not to seem like you, in order to not give off the impression that you don't know what you're doing. So we're just gonna write it a function really quick and put this all in here, right? So we're gonna say, right, we're gonna initially set start to 0, right? And we're gonna say, we're gonna update those as we do some expansion, right? So we're gonna say non-local start longest length palindrome, right? Just so that we're not that um just so that we're not actually updating these locally, but we're actually updating these up here, right? And we're gonna say the same. We're basically gonna do what we did up here, right? So this right here, that should be okay. Now we're gonna erase this. We're gonna paste this in here. Boom. Paste this in here. Boom. And that should be it, right? We're just refactoring, basically, make the code a little bit cleaner. Invalid syntax. Oops, I accidentally put a colon there. I don't know why. But yeah, this code is pretty much it. Like I said, this is O of n squared with O of 1 space complexity. It does look cleaner with the function too, right? Like I said, there isn't a linear time complexity algorithm called Manicher's algorithm. So you spell it, I believe. But I think it's just really obscure. I mean, I just don't really think it's worth learning. I mean, you can learn it if you want. Maybe it'll be useful. Maybe you'll blow your interviewer out of the water. But I feel like you're just going to shoot yourself in the foot if you try and implement this. Because like you're going to practice so many other topics and stuff to prepare for your interviews. Like I just don't really value in it. Yeah, there is a DP solution, like I said, also, but I believe the DP solution is not all of one space, so it's actually less efficient than this. But yeah, this is what we're doing, right? I'm gonna run through. I know this video is already a little bit long. We're already done, obviously. I'm just gonna run through this code again in case you're lost. Just so I always do this with my videos, even though it makes my videos a little bit longer. But the longest length palindrome is initially 0, right? We're initially starting at 0. That's just our base case, right? So we have a for loop, right? So this for loop is basically just iterating through the string linearly, right? And so as we go, right? Hold on, give me a second. I need a mute. I'm gonna sneeze. Oh, I don't think I gotta sneeze. Anyways, so we're gonna linearly go through this string, this input string in our for loop, right? That's what the I is doing here. And so when we're at this B, for example, right, we're gonna expand outwards. So when initially we just have this B, okay, that's our longest palindrome so far. So that gets updated, right? For our longest palindrome so far. Now we're gonna expand outwards. Now remember, right here, the left and the right pointer are initially at the B. So the left pointer goes to the left and the right pointer goes here. But again, we're out of bounds when the left pointer goes to the left of this B, right? So we keep moving forward in the for loop. Now we're at this A. Okay. Again, A, it doesn't update longest palindrome because it's not greater than, this isn't greater than 1. So right now, what we're going to do is, well, the left pointer and the right pointer do match because they're both at the A, right? And we're in bounds. So we're going to expand outwards from here now, right? So what we do now is the left pointer goes, whoops, the left pointer goes here, the right pointer goes here. So now we consider this substring. Okay, that's our longest palindrome now, so that gets updated, right? Great. Right, we update start, here, right? And the longest length palindrome here, right? So that down here we can get the proper, we can do the proper slicing. And again, I know this is a little funky how we do this, but again, it's just a little slight optimization. So we're not doing a bunch of string splicing as we find longer and longer palindromes, longer and longer palindromic substrings as we go along. Because you could do that up here to make it maybe a little bit more readable and cleaner, but it is less efficient. And I don't know, just, I mean, you got to try and give yourself a bunch of brownie points in interviews, which is why I kind of write my code like this. Because I don't think it's hard to understand. I think it's just a little funky, but I think it's useful. Now, again, we also have this part here. We could have even like palindromes, right? So we could have something like this. Obviously, when we expand outwards from any particular character, as long as the left and the right pointer are starting at the same place, we'll never hit these four, right? So that's the point of setting I, the left pointer at I and the right pointer at I+1. So when we're in the for loop and we're here, right, at this first B, left pointer gets set at I, the right pointer gets set at I+1, right? Those match, okay, and expand outwards, left pointer goes here, right pointer goes here, right? Those match. And so this is our longest palindromic substring. And obviously we would never get that here, but we would get that here. So we do need both of these to consider those edge cases. And yeah, I mean, that's our code. I hope this video made sense. I mean, you can ask questions if you need to. But yeah, I mean, I don't think we've done a substring problem like this where we expand outwards especially for palindromes, but yeah. And it is a little confusing, I'll give you that. Substring problems are always a little confusing, at least for me. But I hope this helped. I mean, this code is pretty clean. I hope it makes sense. I tried to optimize it a little bit and write it as cleanly as I can. Hopefully this helped you. And I will see you in the next one. Peace out.